Hello everyone, today we're looking at SAT math, geometry, and trigonometry. Sorry, not geometry, yeah, geometry and trigonometry. We're more specifically looking at lines, angles, and triangles. And as usual, we have 5 difficult level questions. Before we get started with these questions, I need to address a few things on how, like some basic common knowledge before you can solve these problems. The first is that your angles of a triangle are going to add up to 180 degrees. So if you have a triangle ABC, then the angle A plus the angle B plus the angle C, I should actually put measure of angle, which is like this sort of sign. It's not perfect, but yeah, would be equal to 180 degrees. Okay? So that's the main thing that you need to know. Um, as for others, you need to know your basic angle rules. So if you have two parallel lines, right, and you have one line that is, I guess, bisecting these two, well, not bisecting, that runs through these two, then say you have this angle, right? This angle is going to be the same thing as this angle, which is going to be the same thing as this angle because it's a vertical angle. So same thing here, right? And what is this one? Well, if we know that this angle right here is x, right? And we know that this is a straight line. Oh, and before I get to that, in a line, you have 180 degrees as well. So your total is going to be 180. So you have a line right here, and we're splitting it into two parts, say x and y, right? So x and y have to equal to 180 degrees. So if we know x, you can figure out what y is. And then using that, this is all. If this is equal to y, that means that this is equal to y, and this one's equal to y as well, and then lastly this one's equal to y. That's just the basic gist of it. I didn't really do a good job drawing this, but that's basically what you need to know in order to solve these types of problems. Anyways, moving on to our first question, it says in the figure AC is equal to CD. The measure of angle EBC is 45 degrees, and the measure of angle ACD is 104 degrees. What is the value of x? Okay, so we know EBC, we know that AC is equal to CD. All right, AC, wait, let me get this tool. So AC right here is this line from A all the way to C. So one way you can represent this is by drawing this like line right here, and that is equal to CD, which is from here all the way to here. So you can put this line right here as well to represent they're the same. We know that measure of angle EBC is 45 degrees. Okay, so what is the angle? EBC, right? So which one's EBC? Well, we have E right here, B, and then C. So this is the angle that we're having, and that is equal to 45 degrees. Okay, and then lastly, we have the measure of angle ACD. Okay, ACD is equal to 104 degrees. Okay, so one thing to know about triangles. When you have something like this, right? Say both of these sides are the same. That means that the angles that are kind of opposite to them are also equal. So if you see here, the angle opposite to this side right here is this one. And the angles opposite to this one, this side right here is this one. They're the same. So basically what I'm trying to say is when sides of triangles are equal, the angles opposite to them are also equal. So that means that this angle, say it's y, is equal to this angle, and say that is also y. Okay, so we have y, y, and 104 for our angles of one triangle. And given what I said earlier about your angles of a triangle adding up to 180 degrees, you can figure out what y is, right? So we have y plus y, which is 2y, plus 104 will be equal to 180 degrees. So that means that 76 should be equal to 2y, and y is equal to 38 if my math is correct, which I'm pretty sure it is. So what do we have now? We have, let me erase this quickly. Erasing with this tool is kind of a bit of a problem because, yeah, okay. Yeah, so we know that this is equal to, oh, wait, yeah, this is equal to 38. Okay, so now we have one angle of the triangle A, E, and then say this is F, okay? AEF. We have one angle of the triangle. And we can figure out what the second angle is as well. How are we going to do that? Using our vertical angles. So how are we going to find out what's the vertical angle? So this is the vertical angle of AFE. So how are we going to figure out the vertical angle? We're going to use the same method that we used to solve for the angle of y. That is finding out, we know that all sides of the triangle had to, all angles of the triangle had to add up to 180. We also know that, in a straight line, the degree must add up to 180 as well. So we have this angle right here as 104. So that means that we can figure out what this angle is because they have to add up to 180. And we get 76 for that. Okay, so now we have 76, 45, and this angle, let's call it Z. So we can figure out what that angle is by adding them up. 76 plus 45 plus Z is equal to 180. Doing your math, give me 1 second here. 76 plus 45, 180 minus, yeah. So we get Z is equal to 59. Now we have two sides of our, two angles of our triangle, Z and Y. Now we need to figure out what is X. We can do this by adding both these sides and then subtracting that by 180 because again, all the angles of the triangle need to add up to 180. So 59, whoa, that's loud. 59 plus 38 plus X is equal to 180 degrees. And then you can do the math. Give me 1 second. My calculator fell off. And remember, you do have the calculator in your SAT, so you can always use this to make life easier. And by subtracting, we get 83 as our answer. And that would be our answer for this problem. Moving on to the next problem, let me erase, okay, yep. And moving on to the next problem, it says, intersecting lines R, S, and T are shown below. What is the value of X? Okay, I'll tell you two ways to do this, but I'll show you the shortcut way first before going, actually no, I'll show you the long way first before telling you the shortcut way. So the long way is simply to find out what this angle is, use that to find out this angle, and then use that to find out X. How are we going to do that? Well, we know that S is a straight line, and straight lines must have an angle degree totaling 180. So we can just do 180 minus 106, and we get 74 for the angle. And then 74 is one angle, and we have 23 as the other angle. And then we say have Y as our third angle, and this should be equal to 180. We can again use our calculator, 74 plus 23, subtract 180, and we get 83. Oops. Okay, now that we know what now that we know what Y is, we know that X plus Y has to be equal to 180 degrees since R is also a straight line. So X plus 83 should be equal to 180. Subtracting 83 from both sides, we get a value of 97. Oh, wait. 1 sec, did I do math wrong? 23, 74 plus 23, 97. Okay, yep, that would be your answer. The other way to, that is our answer. The other way to solve this problem is by looking at a sort of like shortcut method. So a shortcut method is What this method states is if you have a triangle, say this is our triangle right here, and it has angles A, B, this is terrible, sorry for that, but yeah, and C, and what you're doing is extending out one of these angles right here, and that means that this angle is equal to A plus B. So we're just adding up the angles that are like not involved with this extension and adding those up, and you'll be able to figure out what this is. So again, what you're going to be doing is, one sec. Yeah. So what you'll be doing is you'll do the same step to figure out what this angle is right here, right? And we get that's equal to 74. And then our other angle is 23. Remember, the one that's not touching x. So plus 23, and that will be equal to 97. And that will be your answer. Just a shortcut. You don't need to do this, find a third angle, and then subtract 180, because it just simplifies things out a bit. Moving on to a third problem, it states that in triangle ABC, the measure of angle B is 90 degrees, and BD is an altitude of the triangle. The length of AB is 15, and the length of AC is 23, greater than the length of AB. What is the value of BC over BD? Okay, so this one is kind of, okay, yeah, so this one, it states that the angle of B is 90 and BD is the altitude of the triangle. So first what we need to do is draw this triangle, right? So say you have this right angle triangle like this. This one requires a bit of critical thinking. So this is A, right? You have B, and then you have C. I shouldn't have drawn it right here. And then you're dropping an altitude right here, BD. So what is special about this is when you're dropping an altitude, it'll be perpendicular to, this surface. So that means that this will be a right angle triangle, and this will also be a right angle triangle. Moreover, we know that this triangle right here, which is BDC, will have a right angle and it will have C, right? And we know that the triangle ABC has a right angle and it has the angle C. So what does this mean? We know that the angle BDC will have to equal the angle A. In other words, they're similar triangles, right? And the reason for that is because if you have two angles that are the same, the three angles will have to add up to 180 degrees, right? So that means that if you have, 90 plus C plus X, right? That means that 90 and C are the same. That means that X has to be the same in order for it to add up to 180 degrees. So that means that A and CBD are the same in terms of measure. Okay? So what we can do is set up a proportional relationship in order to figure this out. The reason we can do this is because we're trying to find BC over BD. And that is a fraction and that is proportionate. If you're asked to find out what is BC all alone, we cannot do that because we don't know to what extent is actually we could probably figure that out, but it requires more math because we need to figure out by what times is A B C greater than B C D or whatever, etc. But since we're asked for a proportion, we can solve this out. The way we can do this is BC is your it's your hypotenuse, right? And BD, it's this longer leg, right? So the hypotenuse of your triangle ABC is clearly AC, alright? Oh, wait. Sorry, your hypotenuse of your triangle CBD is actually wait, yeah. Wait one sec. BC. Oh gosh, it's super hard to see. Yeah, BC is your hypotenuse, right? And then your hypotenuse of ABC is AC, right? It's kind of hard to see because this is just an ink and it's not thinner, I guess, but we'll have to make do here. And then the equivalent of BD is, let me see. It would be, I believe, yep, yeah, AB. So we're going to try to figure out what is AC over AB. So what is AC? Sorry, what is AB first? It's 15, right? And then we know that AC is 23 greater than AB. We know what AB is 15, so 23 plus 15. So that is 38. So AC is 38 over AB, which is 15. This is a bit more of an intuitive type problem. When I was looking at this one too, I got a little bit confused and I tried to actually solve for some of the angles and lengths. It did not go out well. So sometimes what you need to look is from a different perspective. Only after I took a short break could I figure this one out. So always make sure to, if you don't understand a problem, just move on, go to a different problem, and then see after doing a lot of other problems and you're sad, come back to that one and see if solving some of those other problems has led to you having a different perspective and being able to solve that one. Otherwise, you could, just skip that one or no, don't ever skip a problem in the SAT because you don't get negative points. Always just make sure to mark something even if you don't know the right answer because, you might get lucky sometimes. Anyways, moving on to your next problem, it says, in the figure shown, WZ and XY intersect at point Q. YQ is equal to 63, WQ is equal to 70, and WX is equal to 60, and WQ is equal to 120. What is the length of YZ? Okay, so first let's mark everything, right? So we know that these two intersect at point Q. So we know that, YQ is equal to 63, right? We know that WQ is equal to 70. We know that WX is equal to 60. And we know that XQ is equal to 120. And what we're trying to figure out is YZ. So what we are going to be using here is your vertical angles. So we know that this angle and this angle are the same because they're vertical angles. We also know that we have two angles that are A. In other words, as I was saying earlier, if you have two angles that are the exact same, you have a pair of similar triangles. And I was saying earlier, if you have similar triangles, that means that they're kind of proportionate. In other words, if you see here 63 and 70, right? YZ. Sorry, let me put it this way. So 63 is our YQ. And if we divide that by WQ, which is 70, that results in a proportion of YQ over XQ. This should be equal to the proportion of YZ over WX. WX is equal to 60. Okay, how can we figure this out? This is because in similar triangles, if you have the small triangle and say you have a large triangle and they're similar, right? If this is X and then this is 2X, right? And then this is Y, say, that means that this one has to be 2Y, right? You're multiplying all the sides by an equal amount, which is why it's proportionate. And remember, we have to be careful. You can only use sides that correspond to each other. In other words, QX and QZ correspond to each other. Since the angles of since the angles of QX and WXQ correspond with the angles of YQZ and QZY. So we need to make sure that your lines kind of match up so that you can get that proportionate relationship. Okay, simplifying this out, you get 9 over 10, right? Because 63 over 70 is 9 over 10, should be equal to YZ over 60. I'll just put X over 60, right? I'm multiplying both sides by, multiplying this left side by 6 to get an equivalent fraction, we get X is equal to 54. And that would be our answer. Moving on to our last problem. One sec. Yeah, there. Oh, come on. Yeah, there. It states, in triangle LMN and RST, angles L and R each have measured 60 degrees. LN is equal to 10 and RT is equal to 30. Which additional piece of information is sufficient to prove that triangle LMN is similar to triangle RST? Okay, so first what we need to do is draw these triangles out. And honestly, it would be way better if I had some sort of tool to do that, but hey, I don't. So we'll just have to make do with what we have. Okay, so, oh, that's a text function. Yeah, there. Oh, yeah, there. Okay, so we have L, M, N. Say this is L. This is M. This is N. Right? And we have this triangle, right? Oh, come on. And then we had this triangle right here. Say they're similar. And say this one, oh, L and R both have 60 degrees, so L is 60. And you'll call this angle right here R to make this more simplistic. That's not supposed to be a B, that's supposed to be an R. This is also 60. Right? And then this is R, S, T. Right? Say it says Ln is equal to 10 and RT is equal to 30. Okay. So let's look at our answer choices. We have Mn is equal to 7. Okay. 7. And ST is equal to 7. Does this work? Okay. One sec. Yeah, so if we look here, what we have is RT is 30 and Ln is 10. So it's highly likely that Ln and RT are like corresponding to each other. In other words, if you have a diagram, more specifically, it would look like R. I'll put it this way: R, T, S instead. And the reason I'm doing that is because you can see it's more proportionate this way. Oh, come on. This feature is really stupid. Okay, that'll do. And then this would be 30, okay? So we look here, if it says ST, since it's still the same side, it will still be equal to 7. But it cannot prove that because remember, in a similar triangle, all sides have to be kind of, when you're multiplying it, it has to be proportional. So if we're multiplying this by 3, that means that this 7 also needs to be multiplied by 3. In other words, it should have been 21 instead of 7. Right? Oh, look here. That's what we have. That's actually correct. Okay, if we look here, in option choice C, it says the measures of angle M and S are 70 and 60 respectively. So if M is 70, and then this is 60, they do not correspond. Okay, but say our calculations or initial thoughts were incorrect, right? Say instead I was wrong, and instead of this being T, right, this is actually S, and then this is the actual T, like we were looking at earlier. Does this work out? One sec. This is, yeah. The troubles. Oh, I'm still using that tool. Okay, say this is S, and then this is T, right? And say this is 7 again, right? Oh, sorry. In this question, we don't have that being equal to 7, so we cannot do that part. Okay, anyways. I also need to delete this. Oh, come on. This is such a major pain in the butt. Okay, just pretend like all those lines and scribbles aren't there. But say this was 30, okay? So if you have both of these angles equal to 60, right? And M is equal to 70. And S is equal to 60. Would this work out? Well, no, it would not work out. And the reason for that is because of our angles of the triangle. If you look here, we have 60 and 70. We have 60 and 60, right? So that means that this third angle would be at 60 plus 70. Wait, 60 plus 70, and subtract 180 minus this. This would have to be 50 degrees, right? And this angle right here would have had to be 60 plus 60, 120. That would have to be 60 as well. And obviously that doesn't make sense, because if you have different angles in your triangle, that means that they're not similar triangles. And lastly, this one doesn't work out either for kind of the same reason. So our answer choice is B. And that's how you solve these types of problems. So I would suggest you look at your your angles of your triangle that add up to 180. Your angles of your straight line, that has to be equal to 180 as well. But I would also suggest you look at some of your theorems that prove for your similarity. Something like your side angle side, angle angle angle, so on and so forth. There are these kinds of theorems, and these are super helpful for looking at proving similar triangles. And that's all that I have for today, and have a great day.